You're listening to Skeptoid. I'm Brian Dunning from Skeptoid.com. The simple proof of man-made global warming. I encourage everyone to listen to this episode, or to read and share its transcript online. Today I'm going to talk about some simple factual observations that anyone can make that unambiguously prove human activity is driving warming of the Earth. I'm not going to mention climate models, politics, predictions, economics, or how many scientists agree or disagree, any of the topics on which there's debate. I'm only going to share a few of the most solid basics, the results of absolute measurements over which there is no debate. These are the things nobody disagrees with, but so few people understand. Despite its contentious topic, this episode is intended to be, and should be, completely non-controversial. I'm only going to make 2 points today, and they are to share 2 of these smoking guns by which we know that this is happening. They're simple to understand, and they're based on basic science that everyone should remember from school. They do not depend on models or predictions, but upon simple, direct observations. They are that the rising CO2, carbon dioxide, in the atmosphere is definitely produced by human activity, and that same CO2 is warming the planet. Nothing in this episode is disputed or is subject to alternate explanations, but too few people are aware of these facts. So let's begin with the proof that the atmosphere's excess CO2 is human-generated. You might think that carbon is carbon, and that if we find there's more CO2 in the atmosphere, its source can't easily be proven. But chemistry is a bit more complicated than that. There are different kinds of carbon, as there are of most elements. They're called isotopes. One isotope of carbon is carbon-14. Now, cosmic rays bombard the Earth at a rate that's more or less constant over time. When they do, they strike atoms in the upper atmosphere, kicking out neutrons. These neutrons then collide with the most common atoms in our atmosphere, nitrogen. This collision kicks a proton out of the nucleus and turns the nitrogen into carbon with 2 neutrons too many, the unstable and radioactive carbon-14, instead of the normal stable carbon-12. You've heard of carbon dating. This is done by comparing the relative amounts of carbon-12 and carbon-14 in the sample. Living things, like animals and trees, are in equilibrium with the atmosphere. As they eat and breathe and interact, they contain the same proportions of carbon isotopes as the atmosphere. When they die, that carbon-14 decays over a long time, and since the organism is no longer eating and breathing, no new carbon-14 comes in, and all its carbon eventually becomes carbon-12. Fossil fuels, like oil and natural gas, come from plants that died millions of years ago and have no carbon-14 left. The CO2 produced by burning fossil fuels contains only carbon-12. When a forest fire burns, the CO2 in the smoke came from living or recently dead fuel, so the smoke contains the same proportions of carbon-12 and carbon-14 as the atmosphere. This is the case with nearly all natural sources of CO2. We can carbon date the CO2 in the atmosphere and tell exactly how much of it comes from humans burning fossil fuels. It's a hard measurement. It leaves no room for interpretation. There is one natural source of CO2 that contains only carbon-12, and which is often pointed out by climate deniers as the real source of all this new carbon-12: volcanoes. Volcanoes worldwide constantly erupt, both on land and under the sea. They do so at a fairly constant rate. We measure their output, and we know that annually, worldwide volcanic activity averages about 200 million tons of CO2 added to the atmosphere, all with carbon-12, which is indistinguishable from the carbon-12 produced by burning fossil fuels. However, each year, we measure a total of about 29 billion tons of CO2 added to the atmosphere. That's more than 100 times the amount volcanoes can account for. The only possible source of all the rest of that new CO2 is fossil fuel burned by humans. This, in short, is the smoking gun that proves the increase in CO2 in the atmosphere is caused by humans burning fossil fuel. It's not a conjecture or a model or a prediction. It's a measurement that anyone can reproduce. And isotopes are isotopes and don't have alternate explanations. Some have said that 29 billion tons is not a problem because of how small that is compared to the atmosphere's total existing carbon load. It's true that 29 billion tons is a drop in the bucket compared to the 750 billion tons that moves through the carbon cycle each year, which is our name for the natural processes by which carbon is exchanged between the atmosphere and the oceans and vegetation. Each year, of that 750 billion tons, the ocean absorbs a net gain of about 6 billion, and vegetation absorbs a net gain of about 11 billion. They're only able to absorb about half of the 29 billion we're adding. The other half, about 15 billion tons each year, remains in the atmosphere after maxing out the Earth's ability to absorb it into its system. These numbers, too, are reproducible measurements, not conjectures, not models, not predictions. The system is provably absorbing all it can, but still unable to keep up. Okay, our second smoking gun, proof that that human-generated CO2 is warming the planet. We also do not need models or predictions to directly measure the source of heat in the atmosphere. There are 5 gases that are primarily responsible for the greenhouse effect. They are CO2, methane, water vapor, nitrous oxide, and ozone. We can tell this because of spectroscopy. Spectroscopy is a method of detecting elements by looking at how electromagnetic radiation passes through them. Different elements have electrons in orbits at varying energy levels, and this affects the way they resonate. It's the reason why neon lights produce different colors depending on what gases we fill them with. It's also the way we're able to tell what proportions of hydrogen, helium, and other elements are in distant stars. The spectrum of light coming from them has peaks and valleys that are chemical fingerprints of exactly what gases are in them. The Earth's surface is warmed by the sun, and as a warm globe in space, the Earth itself emits that same heat right back out, as infrared radiation. If we go outside and point a spectrometer at the sky, we can see there are peaks and valleys in the infrared spectrum. Some wavelengths of heat fly right out into space unhindered, while other wavelengths are absorbed by the atmosphere, and that heat stays there, where we're able to detect its wavelength with our spectrometer. In exactly the same way as we're able to identify the elements in a distant star, we're able to identify exactly which greenhouse gases are trapping the Earth's radiative heat. This is how we were able to identify those 5 main gases. And this isn't new. We've understood this for 200 years. It's a direct measurement that anyone with a spectrometer can reproduce. Not a model, not a prediction, not a guess. Water vapor, which is the most prominent, defines the basic shape of the greenhouse spectrum. Most of the infrared radiation that escapes the Earth goes through a window left open by water vapor, which we call the infrared window. This window in the spectrum, which is pretty wide, is centered around a wavelength of about 10 micrometers. At higher and lower wavelengths, water vapor absorbs much of the Earth's radiated heat. So the Earth has always relied on this open window in the spectrum to allow the excess heat to escape. Now, one end of the infrared window is overlapped by CO2's absorption range, which is centered around 15 micrometers. The amount of CO2 in the atmosphere acts like a sliding door which widens or narrows the infrared window. As CO2 increases, the infrared window is narrowed, less radiation escapes into space, and more heat is absorbed by the atmosphere. At the other end of the infrared window, around 7.5 micrometers, methane has a similar effect, contributing about 1/4 as much warming as CO2. Spectroscopy is hard science. We don't have to model or predict. Simply by pointing our instruments at the sky, we can, right now, directly observe and identify the greenhouse gases and measure exactly how much radiative energy the atmosphere is absorbing and keeping here on Earth. This direct, non-ambiguous spectroscopic reading is the smoking gun that proves the excess heat energy being trapped in our atmosphere is due to CO2. That excess CO2 is produced by humans burning fossil fuels. Now, we've also measured the Earth's infrared spectrum from space, looking down from satellites to see which wavelengths of heat energy are being trapped by gases in the atmosphere and which wavelengths are escaping. We started this in 1970 with the IRIS satellite, giving us a baseline to compare against future measurements. It was followed in 1996 with the Japanese IMG satellite, and again with the AIRS satellite in 2003 and the AURA satellite in 2004. They paint a very clear picture. We subtract new readings from the old readings to see the delta, to see exactly where in the spectrum any change has occurred. Within that infrared window, defined by water vapor, there's one big spike. It is the 15 micrometer range of CO2. This is explicit, unambiguous proof that the increased heat in our atmosphere is due to CO2. It has nothing to do with models or predictions. It's a direct observation. It is hard chemistry and basic physics, not guesswork or extrapolation. As we burn fossil fuels, the CO2 in the atmosphere increases, the infrared window narrows, less heat radiates away from the Earth, and more heat goes into the Earth's system. These are simple, solid facts. In this episode, I've tried to limit everything to just facts that are not in dispute. That means I haven't included any estimates or predictions. Why? Because I'm trying to take opinion and ideology-driven spin completely out of the picture. I don't have an answer or a solution for people who prefer to view this particular science question through the filter of an ideology. Earth science measurements and facts are ideology-free, just like astronomy and mathematics and zoology. The impact that human use of fossil fuels is measured to have already made to the Earth system is bewildering. It is from this point, from the non-ambiguous, factual, black and white characterization of our atmosphere and oceans, that we must ask ourselves whether any ideological twisting of the facts is truly the best path forward. We have to accurately understand a problem in order to devise a properly informed solution. Please, if you have any curiosity about any of the topics we've just discussed, see the references section at the bottom of the transcript of this episode on Skeptoid.com, where you'll find links to articles and videos that are both thorough and easy to understand. You can go into much greater depth if you're so inclined. What's important is what you choose to do with this information. And that part, I will leave up to you. You're listening to Skeptoid, a listener-supported program. I'm Brian Dunning from Skeptoid.com.